Okay, so here we have a problem taken from the textbook. It's question from 7B, and we're specifically looking at question 4A. And this question has to do with composite functions. And what we're dealing with is two functions. One function gx equaling x squared, and another function which is fx equaling 3 sine 2x. And we're looking to find f of g and g of f respectively, and to be able to state their range and their maximal domain for each of these functions. All right, so getting started, what I would do is I would first start off by just ascertaining what gx and what fx is. So it's just nice and easy just to be able to write them out, first of all. And then in the first instance, I'm going to have a look at f of g. Now, f of g, this means that I'm writing f gx, and it means I'm substituting gx into fx. And this would give me 3 sine 2x squared. And I might put my brackets around there. Okay, seems like a simple enough equation. However, we have this x squared within the circular function. Now, I want to ascertain whether or not the composite function, and from the composite function, I mean this function, exists for the domain that is given. And what I might do here is I would, apologies, just get rid of this stuff. But I would be looking at f g, my domain for each, and my range for each. Now, my domain given by this set of equation means that it's all real numbers. So that's quite easy to ascertain. That's all real numbers. But my range, however, is going to be dependent on each of the functions. So if I look at fx, my range for fx is going to run from -3 to 3, because it's a circular function with an amplitude of 3. Therefore, you know, my maximum value is going to be -3. Minimum value is going to be -3, maximum value 3. My domain, however, for g, because g is x squared, is going to run from 0 to infinity. And the key question that I'm asking, does f of g exist for the domain given, is I want to be able to establish whether the range of g belongs to the domain of f. Now, if I have a look at this, so my range of g is given by 0 to -infinity, and does that fit within all real numbers? Yes, it does. Therefore, f of g exists. Now, what I want to then be able to do is be able to state what my range of f of g is going to be, and what my domain of f of g is going to be. So if I'm looking at my range, this is still just a circular function, okay? And it's going to be bouncing from -3 up to 3 and back again, like so. My domain, because I've said here when I've looked to see if f of g exists, well, it exists for all real numbers, therefore my domain is real numbers. Okay. If I look the other way, though, and I'm having a look at g of f, and I'm just going to write these out, gx equals x squared, fx equals 3 sine 2x. If I write g fx as a function, this is going to give me 3 sine 2x, and that's all squared. Now I can do a little bit further work with this and just expand it. Squared. Okay, 9 sine 2x all squared. And, or we would write that probably in a more valid way. Probably take this out. Okay, that's what our function should look like. Now we want to see if g of f exists, so we would start by putting g, f, domain, range. The domains for both g and f are all real numbers. The range for g is 0 to infinity. For f, it's -3 to 3. And to ask if it exists, does g of f exist? What we're really asking is, does the range of f belong to the domain of g? So my range of f is this. Does that fit within the domain of g? Yes, it does. Therefore, g of f exists. Now, what I need to ascertain is what my max or range, don't need this max idea happening here, but the range of g of f. This range, let me just note it up here. This range is going to be, well, what happens from if I'm looking at this function here, what are my maximum and minimum terms? Now, we can say here that my amplitude is going to be 9, and normally we would think, okay, well, that's going to run from -9 to +9 because it's a circular function. But because it's got this sine squared, what it means is effectively that every negative value is going to become positive. So the minimum value that we can have here for our range is going to be 0. And the maximum range maximum value that we can have for our range is going to be 9. Now that's all dependent because of this term specifically being squared. Okay, so there can't be any negative values there. Obviously then if we talk about our domain of g and f, okay, this is all real numbers and this is our solution. And all correct.